A random variable is a function that assigns a number to every possible outcome of an experiment. For example, imagine we have a bag with 10 different colored balls. This is our sample space. Our experiment is to pick a random ball. So suppose that if the ball is red, we assign it to number 1. If the ball is blue, we assign it to number 2. If it's green, 3, and so on. Each number is the value of the random variable for that outcome. Mathematically, we denote the random variable by a capital letter like C for ball color. This is the abstract function. The numbers you get, 1, 2, 3, and so on, are the values of that function for each specific outcome. One experiment can give us multiple random variables. For example, besides color, we also might be interested in the weight of the ball. So each ball has a color and a weight. Weight is a different function from the sample space to the real numbers and a different random variable. So for example, if the ball is red, we assign it to 5 grams. If the ball is blue, we assign it to 6 grams. And if the ball is green, we assign it to 9 grams. This is a completely different random variable, and it's a different function. So we can denote it W. You can also define random variables as functions of other random variables. So for example, if we convert the ball weights from grams to ounces, we are going to have 0.31, 0.17, and 0.21. We can denote this random variable W bar. W bar is now another random variable. Each outcome determines its value just like W did. Any function of a random variable is also a random variable. So formally, a random variable is not random and it's not really a variable. It's a function from the sample space to the real numbers. We use capital letters to denote random variables and lowercase letters to denote numerical values. There are 2 types of random variables: discrete random variables and continuous random variables. A discrete random variable takes specific countable values. You can list them all individually. For example, imagine you roll a 6-sided dice. The possible outcomes are 1, 2, 3, 4, 5, or 6. Each number is a value of the random variable. You cannot roll 3.5 or 2.7. Only integers on the dice. Notice that the dots are separate. Each dot is a possible outcome. That's why it's discrete. Only these values are allowed. A continuous random variable can take any value in a range. There are infinitely many possibilities, so you can't list all of them. So for example, imagine you're measuring the height of a plant in a garden. The heights could be 12.1, 12.3, 12.4, and so on. Any number in the range is possible, so the values are continuous. The curve shows that any value along this range is possible. So unlike discrete variables, there are no separate dots, it's continuous. Another example would be temperature in a city during a specific day. It could be 21.2 degrees, 21.3 degrees, and so on.